everyone, welcome to our next video on basic chemistry. Today I'll be talking about the nomenclature of alkanes, so you will learn how to name alkanes according to IUPAC system. So let's get on with it. First of all, let's see what alkanes are. So alkanes are saturated hydrocarbons. Hydrocarbons are molecules that contain carbon and hydrogen in their structures. A saturated hydrocarbon means that it's a molecule which has only single covalent bonds in its structure. So there are no double or triple covalent bonds present in the structure. Saturation means that nothing can be added to these molecules. So alkanes are saturated hydrocarbons with the general formula CnH2n+2. Now, when we try to name these molecules according to IUPAC system, we use certain prefixes for the number of carbon atoms in a chain. So if you have one carbon in the molecule, the prefix meth is used. If you have two carbons, the prefix eth is used. If you have three carbons, prop. For four carbons, but. For five carbons, pent, hex, hept, oct, non, and dac. So these are the prefixes used for the number of carbon atoms in an alkane chain. And the name always ends with ANE. So these are some of the IUPAC rules. Others we will discuss in the next slide. So the name of an alkane will always end with ANE. So these are some of the names of very simple alkanes. If you have one carbon atom in a structure, obviously it will have four hydrogens attached to it. So for one carbon we use the prefix meth and the name ends with ANE, so the name methane. For two carbons, six hydrogens are there. The prefix used for two carbon chain is eth and the name ends with ANE because it belongs to the alkane class of molecules. For three carbons, the name will be propane. For four carbons, it's butane. Five carbon chain, pentane, and six carbon, hexane, heptane, octane, nonane, decane, and so on. So this is how you name basic skeleton of an alkane molecule. These are certain IUPAC rules which you need to remember while naming alkanes. The very first and basic rule that you will follow for naming almost all of the organic molecules is to select the longest possible chain in the molecule. So there's a carbon chain in the molecule and you have to select the longest possible chain. Longest possible chain means a chain with the maximum number of carbon atoms. So once you select the longest chain, you will know how many carbon atoms are there and you will know the correct prefix to use for that particular molecule. The second rule is that you have to identify the number and types of substituents present in the molecule. Now, what does this mean? These carbon chains may have certain substituents attached to the chain. Now, these substituents in case of alkanes would be alkyl groups, which we will discuss in the last slide of this video. So these substituents may be present at any position in the chain. It could be one substituent or it could be more than one substituents present in the chain. So you have to identify the number of substituents and the type of substituent. So you have to know how many and what substituents are present in the molecule. Now, when you have done that, you have to number the carbon chain. Like you have to assign numbers to all the carbon atoms in the chain. Now, for that, you have to start from one end of that carbon chain. And you have to start numbering from a side so as to give all the substituents the lowest positions or the locants. If you have one substituent, you start from a side so as to give the lowest possible position to that substituent. If you have more than one substituents, then you have to take into account the positions of all the substituents present on that chain. Finally, you name the molecule as follows. So these are the fragments of the name. First, you have to write the position followed by the names of all the substituents. So you have to mention the positions and names of the substituents first. Then you write the prefix for the number of carbon atoms in the longest chain. For example, if the longest chain has 4 carbon atoms, then you use the prefix but, and then finally end the name with ANE. So first you have to mention the substituents, and in the end you have to mention the name of the parent molecule. Now the parent functional group in these molecules is of course the carbon-carbon single bond. So for that the name always ends with ANE. So the parent name in alkanes ends with ANE, and that will always come at the very end. So you have to mention everything that has lower priority before the parent name. The parent name comes at the very end, and that you can see in other functional groups when we will be discussing in this series later on. So let's see what other things you need to remember when you name the alkane molecules. So you always have to put a hyphen between the position and the name of the substituent. So first you have to write the position of a substituent followed by the name of that substituent, and both the position and the name of the substituent will be separated by a hyphen. These are certain things you have to remember while naming these organic molecules according to IUPAC system. If you have different alkyl substituents present in the molecule, then you have to mention them while writing the complete name of the molecule in alphabetical order, right? So if you have 2 different substituents, you have to mention the one that comes first in the alphabetical order before the one that comes after in alphabetical order. If you have more than one similar substituents present in the molecule, then you have to use another prefix for those substituents like di, tri, and tetra for 2, 3, or 4 similar substituents. And you have to separate the positions of these similar substituents by comma, as I have done here, but this is not the position. These are just the number of substituents for which you have to use the prefix. But if you have more than one similar substituents, you have to separate the positions of all those similar substituents using a comma. Let's see some examples. So we have a simple straight chain molecule. I hope you understand what this line structure means. So if nothing is written in this structure, that means it has carbon atoms. So it has 1, 2, 3, 4, 5 carbon atoms. And it is understood that because all of these carbon atoms are sp3 hybridized, there are only carbon-carbon single bonds. So you have to add the corresponding number of hydrogens so as to satisfy the valency of that carbon. So if you have a terminal carbon here and it is attached to another carbon through a single bond, it means this carbon has formed one bond here, so it should have formed 3 other bonds with hydrogens. So this carbon will have 3 hydrogens attached to it. This carbon will have 2 hydrogens attached to it, 2 hydrogens here, 2 hydrogens here, and 3 hydrogens here. So this is understood that appropriate number of hydrogens are always present in this molecule, even if they are not mentioned. So we have 1, 2, 3, 4, and 5 carbon atoms in the chain. So the first rule is to identify the longest possible chain. We will name these molecules in these examples using those rules one by one. So the first rule is to identify the longest chain. This molecule has only one chain that contains 5 carbon atoms. The second rule is that you have to identify the substituents, the type and number of substituents present in this molecule. There are no substituents attached or no branches attached to these chain. It's a straight chain, no branching, so there are no substituents. It's a simple straight chain molecule with 5 carbons. So you have to write a prefix for this molecule, and that is pent for 5 carbons. So you write the prefix pent and then end the name with ANE. So the name pentane for this molecule. If we have a branched chain, now we have a molecule that can have more than one chains. So the first rule is to identify the longest possible chain. Let's see how many chains are possible in this molecule. So we have 1, 2, 3, 4, and 5 carbon atoms in this chain. We have another chain here starting from here. 1, 2, 3, 4, and 5 carbons are also present in this chain. And then we have another chain. 1, 2, 3 carbons are there. So you have 3 possible chains, 2 with 5 carbons and 1 with 3 carbons. Obviously you have to ignore the one with 3 carbon atoms because that is not the longest chain. So you have 2 possible chains with highest number of carbon atoms, and that is this straight chain, and the other one is this chain, both with 5 carbon atoms. Now if you have such a situation that you have more than one chains with equal and highest number of carbon atoms, then you have to select that chain which has highest number of substituents present in that chain, right? So if a chain has, for example, 6 carbons and 1 substituent, and another chain in the same molecule has 6 carbons with 2 substituents, then you have to select the chain with 6 carbons and 2 substituents, not with the one with 6 carbons and 1 substituent. So we will check out both the chains here. This chain has 1, 2, 3, 4, 5 carbon atoms with 1 substituent as a CH3. This is a methyl substituent, and this chain here also has 5 carbon atoms with a CH3 substituent, a methyl substituent here. So both the chains have 1 substituent, right? So now it's up to you. You can select any of the 2 possible chains. So for convenience, I select this chain, right? So this is a 5 carbon chain. You have identified the number and type of substituents. It has 1 substituent, and that is a methyl substituent. The next rule is to number the carbon atoms in the chain. So you have to assign numbers to all the carbon atoms, and the rule is that you have to start numbering from one end, and that would be an end from where all the substituents present in the molecule get the lowest position of the locant. So we can start from this end to have this CH3 substituent at carbon number 2, 1, 2, 3, 4, 5, or we can start from this end, 1, 2, 3, 4, 5. So the methyl from this end is at 4, but from this end it is at 2. So the rule says that you have to start numbering from a side where the substituents get the lowest position. So we have to start from this end, 1, 2, 3, 4, 5. So now the methyl is at carbon number 2. So we have done everything possible, and now we have to name the molecule. So first you have to write the position and the name of the substituent. So the substituent is at carbon number 2, and it's a methyl substituent, and you know the rule that the position and the name of the substituents are separated by a hyphen, and then comes the parent name. So the parent name or the parent molecule has 5 carbons, so the prefix pent again, just like this, and because it belongs to the alkane class of molecules, so the name ends with ANE. So finally the name would be 2-methyl, 2-methyl. 2 is the position of the substituent, methyl is the name of the substituent, separated by a hyphen, then prefix for the number of carbon atoms in the chain, and finally the name ends with ANE. So the final name is 2-methyl pentane. Let's see another example. Now we have more branched chain or molecules, so we can have many chains possible here. So we start off with the first one, 1, 2, 3, 4, 5, 6, 7. This chain has 7 carbon atoms. Then we have another chain 1, 2, 3, 4, 5, 6. This chain has 6 carbon atoms. We can have another chain 1, 2, 3, 4, 5, 6, 7. So we have another chain with 7 carbon atoms. Then we have this chain 1, 2, 3, 4 and 1, 2, 3. So we can have 5 chains possible. One with 3, one with 4, one with 6 and 2 with 7 carbon atoms. So the highest number of carbons we can have in this in a chain in this molecule is 7. So you have to ignore all the other chains like this one with 3 carbons, this one with 4 carbons and this one with 6 carbon atoms. So you ignore all of them. You have 2 left behind with 7 carbons. One is this chain here and the other is this straight chain with 7 carbon atoms. So the rules say that you have to select that chain which has the highest number of substituents. So if we select this straight chain with 7 carbons, we have 2 substituents, a methyl substituent here, a methyl substituent here. This is how we write a methyl substituent. This is a CH3, 1 carbon with 3 hydrogens. This is also 1 carbon with 3 hydrogens. So this straight chain has 2 substituents. If we select this chain, this also has 2 substituents. So now it's up to you. You can select any of the 2 possible chains with 7 carbons. So again, for convenience, we select this chain with 7 carbon atoms, which has 2 methyl substituents attached to it. Next rule is to how to number the carbon chain. So you start off from here where the substituents are at 2 and 3. If you start from here, then the substituents are at 5 and 6. Right? So from here, they are closer together. We have more than 1 substituent, so you have to take into account the positions of both the substituents. Right? You can do it through another trick, like you can add the positions of the substituents. So if you start from here, one is at 2, the other is at 3. 2 plus 3 is equal to 5. If you start from here, one is at 5, the other is at 6. So 5 plus 6 is equal to 11. So you start from an end where the sum of both the substituents is lower. So you start from here, 2 plus 3 is equal to 5, that is lower than 11. So we start from the left, 1, 2, 3, 4, 5, 6 and 7. So we have 2 substituents now which are similar in nature, and as I told you, if you have more than 1 substituents, you have to show the positions of both the substituents with a prefix di here for 2 substituents. So this is a 2,3 dimethyl because both are methyl substituents. So this is a 2,3 dimethyl, and then we have 7 carbons in the chain. So the prefix hept and the name ends with ane. Here you can see that we have separated the positions of both the methyl substituents with a comma, and the position and the name is separated by a hyphen. Now we have another example, and let's see how many carbon atoms we can have in the longest chain. So 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3. So the longest possible chain has 7 carbons again. So there are 2 chains where we have 7 carbons. This straight chain has 3 substituents, a methyl, and now we have a 2 carbon chain, an ethyl chain here, right? Branch here. And this chain here also has 7 carbons with 1, 2 and 3 substituents. So again, you have 2 similar chains with similar number of carbon atoms and similar number of substituents. Now the problem is from where to start the numbering. From here, the substituents are at 2, 3 and 5. So 2 plus 3 plus 5 is equal to 10. From here, they are at 3, 5 and 6. 3 plus 5 plus 6 is equal to 14. So we start from here where the sum is 10. So we have 2 methyl substituents and an ethyl substituents. And the next rule is that when you have 2 different substituents, you write them in the name in alphabetical order. So ethyl comes first than the methyl substituent. So we write the position and the name of the ethyl substituents first, so which is at 5. So 5 hyphen ethyl, then hyphen, because we have a name of the substituent and position of a substituent, so that is separated by a hyphen again. And then we have two substituents at position 2 and 3 which are similar, so the prefix di is used for the methyl substituents. Then 7 carbons in the chain, and the name ends with ANE. Now here is another question. We know that ethyl comes first than methyl in alphabetical order, but here this is a dimethyl substituent. Then still we have written dimethyl after ethyl, because despite the fact that D comes first. Now while naming a molecule and using the alphabetical order, you have to ignore this substituent, this prefix di, tri, tetra or penta for while using the alphabetical order. So you have to compare E and M here, not comparing E with D in alphabetical order. So this prefix is ignored while using the alphabetical order. So this is 5-ethyl 2,3-dimethyl heptane. This is another example. Let's see how many carbons we can have. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can have 8 carbon atoms possible in the longest chain, and we have 2 substituents present in both the chains, which are ethyl substituents in this case. If you select this chain, see, with 8 carbon atoms, we have an ethyl substituent here and an ethyl substituent here. From this end, the ethyl substituents are at 4 and 6. 4 plus 6 is equal to 10. From here, they are at 3 and 5. 3 plus 5 is equal to 8. So we will start numbering from this end. 1, 2, 3, 4, 5, 6, 7, and 8. So they are at 3 and 5. This is a 3,5-diethyl oct for 8 carbons, and the name ends with ANE. This is another example in which we have 8 carbons here in the chain, and 1, 2, 3, 4, 5, 6, 7, 8 carbons here as well, right? So 6, 7, 8 here, and 8 carbons in this chain also. And both the chains have similar and equal number of substituents. Now we have an ethyl substituent here and a propyl substituent. 3 carbon is a propyl substituent. So from this end they are at 3 and 5. From this end again they are at 4 and 6. So we start from here, 1, 2, 3, 4, 5. So this is a 3-ethyl 5-propyl. Again we use the alphabetical order, so E comes first, followed by P. So this is a 3-ethyl 5-propyl oct for the 8 carbons in the chain, and ANE is the ending of the name. So this is how you name alkanes according to IUPAC system. Now what are alkyl groups or substituents in case of alkanes? You can have, or you can get, an alkyl group if you remove one of the hydrogens from an alkane, and that removal could be from any position, and that will give you a different alkyl group or substituent. So if you remove one hydrogen from an alkane, you will get an alkyl group. Let's see some examples. This is a CH3 alkyl group, and this is obtained by removing one hydrogen from methane. So this becomes methyl or methyl substituent. This is a 2-carbon chain, and you can see that an ethane has 6 hydrogens. Here we have 5. So 1 hydrogen has been removed from ethane. So this becomes ethyl. For 3-carbon chain, this is propyl. Now propyl can have 2 different types of alkyl groups. If the attachment is from here, you see that this propyl is a straight chain alkyl group or propyl group. So we call it an N-propyl substituent. If the attachment to the main chain is from the 2nd carbon, then we say that it is an isopropyl group. Both have 3 carbons in this alkyl substituent, but the attachment of one is from the 1st carbon, from the primary carbon, and the attachment of the 2nd is from the secondary carbon. This is N-propyl and this is isopropyl. If we have 4 carbons in the substituent, then we can have again 4 different types of substituents possible. If the attachment is from the first carbon, then we call it an N-butyl substituent. If the attachment is from the second carbon, then it's a secondary butyl substituent. If this 4 carbon substituent is also branched, you see 3 carbons are here and then we have a branch here. If the attachment is from this carbon, then we call it an isobutyl alkyl substituent. If the attachment is from a tertiary carbon, this is a tertiary carbon, so there are 1, 2, 3 and 4 carbon atoms, and the attachment is from this tertiary carbon, so this is a tertiary butyl substituents. We can have an new pentyl substituent with 5 carbon atoms. So this is how you can name alkanes. You can find different examples. If you find an example difficult to name according to IUPAC system, let me know in the comment section. I'll be happy to answer. This is Dr. Salman Zafar signing off from today's video. Thank you for joining. Stay tuned.